Okay, welcome back to Calculus 2. We are going to be looking at some more examples of finding arc length. This one is a doozy. You'll love this. So find the arc length of y equals 1/2 x squared on the interval 0 to 3. We can graph it if you'd like to, but we don't really have to. But 1/2 x squared is just going to be a parabola going from 0 to 3. And we're just trying to figure out, like, what is this arc length sitting right here? Okay. All right. So we picked a nice easy one. So first step is we're making an arc length. Okay. So we're going to say S is equal to, let me write the formula down first. So this is S is equal to this, the integral from 0 to 3 of the square root of 1 plus f prime of x squared. Okay. All times dx. Okay. So let's just take this in parts. So the first thing we have to do, figure out the derivative. Well, 1/2 x squared, that's a pretty easy derivative. So that's just x. Okay. And now what we're going to do is we're going to say f prime of x, and we're going to square it. Okay. That is equal to x squared. Okay. And then I think the next thing that we're going to be doing here is we're going to be adding 1 to it. So f prime of x squared plus 1 is going to be, and then we'll take the square root. Okay. So we want the integral of 0 to 3, right, of the square root of 1 plus x squared dx, and that is going to be my arc length. And that's S. Okay. Now, why is arc length S? I have no idea, but that's it was from a long time ago that they did that. Okay. Now, this integral, it's not just 1 plus x. That was the last one. This is 1 plus x squared. So it's the square root of a square, which means we need a triangular substitution. Oh, that's right. There was a reason we taught you that, wasn't there? Be on the lookout because integration by parts is coming up too. So what we're going to do is we're going to go ahead and say we have a plus, so Pythagorean's theorem, a squared plus b squared is equal to c squared. So we need a 1 and an x here, so that my square root here is going to be x squared plus 1. Okay, here's my theta. Okay, we're just going to leave it at 0 to 3 for now. We're going to push it back into x's, and I'll tell you why when we're about done with that. So we're going to be able to say that the tangent of theta is equal to x of 1. X is equal to tangent of theta. So dx is equal to secant squared theta d theta. Now let's go ahead and say, oh, by the way, what is secant equal to? So secant of theta is equal to hypotenuse over adjacent. That's equal to the square root of x squared plus 1, technically over 1, but that's not going to be too big of a deal. So let's go ahead and substitute this back in. So we have s is equal to 0 to 3. I'll just put a little x equals so I can remind myself that our limits are in x. 1 plus x squared, that's secant theta. What was my dx? My dx is secant squared theta d theta. Oh joy, we've got to calculate out the integral of secant cubed theta d theta. All right. So again, I would urge some of you to memorize this one because it shows up so much. And again, we're trying to figure out the arc length of a parabola. And then all of a sudden we come up with secant cubed. What the heck? But it comes up frequently, and as much as people try to avoid it, it's just like they just fall into it because it's so ubiquitous, it just happens. So you have to remember that we're going to integrate this as secant squared theta times secant theta, and that's the theta, and that's how we're going to set this thing up. So we're going to say, remember, it's integration by parts because we have a function times a function that has to be integration by parts. So we're going to say u is equal to secant theta d theta du is equal to derivative of secant is secant theta tangent theta. dv is whatever's left. That's got to be secant squared theta d theta. That's the reason why I reserve my secant squared, is because integrating secant squared isn't a big deal. It's just tangent of theta. Okay. So we have to do our swish and flick here. So we're going to say this is going to be, we have s is equal to the integral from 0 to 3 of secant cubed theta, which is equal to secant theta tangent of theta minus the integral of secant theta tangent theta times tangent theta. So tangent squared theta d theta. Okay. And it's like, oh no, what's tangent squared? Because now I can't integrate that. So we have sine squared plus cosine squared is equal to 1. Divide everybody by cosine squared. And we end up with tangent squared theta plus 1 is equal to secant squared theta. So tangent squared is really right, is equal to secant squared theta minus 1. So we could say that we have secant theta tangent theta, and this is still going to go from 0 to 3, x equals 0 to 3, minus the integral of, and then we're going to say secant theta times secant squared theta minus 1 d theta. So we have to clean this up a little bit. So this is going to be secant theta tangent theta minus integral of secant times secant squared, which is secant cubed, minus times a minus is a positive. So we have plus secant theta d theta. This integral is applied to both of these pieces here. So actually, I'm going to distribute it. Just go ahead and write it that way. So remember what our original thing was. Our original thing was secant cubed theta is equal to all of this. Well, here's a integral of secant cubed theta. Why don't I just add secant cubed theta to both sides, okay, in order to get rid of that problem? And we'll be able to say that we have two integrals of secant cubed theta is equal to secant theta tangent theta. That's the derivative of secant, remember, plus the integral of secant. Okay, and again, it's going to go from 0 to 3. And if you remember the integral of secant, remember your integration facts. That is the natural log of secant theta plus tangent theta. Okay, and then we have secant theta times tangent theta. So we have derivative, and the integral of theta is equal to secant cubed theta d theta. And I'm going to say divided by 2. So it's the average of the derivative and the integral of secant. Okay. That's where the plus 2 came from. Okay, going way back to the beginning. Remember, I didn't change my integration into thetas because that would have been messy. What I'm going to do is say, go back to my original problem here with my original triangle and say secant is equal to square root of x squared plus 1 over 1. And we'll be able to say that. So my arc length at this point, so we'll go back to our arc length, is equal to, I want the square root of x squared plus 1 over 1 times tangent. Remember what tangent is? It's x. Plus the natural log of secant, that's going to be the square root of x squared plus 1, plus tangent x. Okay? And what are we doing? We're going from 0 to 3. So we can go ahead and plug 3 in here. So we're going to say we have s is equal to 3 squared. It's going to be 9. 9 plus 1. So we have the square root of 10 times 3, right? Because that's what times is, plus the natural log of 3 squared is going to be 9 plus 1 is 10 plus 3 here. Okay. I think that's what we have for this piece here. Minus, and then we plug in 0. So we have 0 squared plus 1. That's going to be 1. Square root of 1 is 1 divided by 1 times 0. So that's going to be a 0. We plug in 0 here, we get 0 squared plus 1. So we have natural log of 1, 0. Natural log of 1, which is 0. So here we have 3 root 10, okay, plus natural log of 13. I'm sure that's a delightful number. I don't really care what that is. But if you're going to put it in a calculator, which is fine because this is not as aesthetically pleasing as I would have liked, but we can plug that in the calculator and get a nice answer for it. And then we can go ahead and say that's going to be our answer. Okay. So there we go. And that's how you can do a problem. Like that one gets to be a little bit longer. Okay. Don't answer yet. They get worse. Okay. So let's go ahead. Let's do our next example here. This one is kind of clever, and you're going to see these a lot. Okay. So my next example is calculate arc length of y equals x squared over 2. That'll be a nice derivative. Minus 1/4 natural log of x on 1 to 2. Okay, again, we don't have to graph this. That's going to be fine. But we'll go ahead and we'll do our thing. So remember what our formula is. And being able to, like memorizing the formula, the best way to do that is write it down a lot. So S is equal to the integral from A to B, 1 to 2, of the square root of 1 plus f prime x squared dx. All right, now we'll just take this apart. So the first thing I got to do, what is f prime of x? Well, we're adding two functions here. Okay, so this the derivative of x squared over 2 It's just going to be x. Okay, no big things for that one. That'll be pretty easy. Minus, that's the derivative of natural log is 1 over x. So this is going to be 1 over 4 times 1 over x. I'm going to write this fancier and say this is x minus 1 over 4x. And we don't want to get lost in where did that x come from and how did it get there. Okay, but that's my f prime of x. Okay, now what do we have to do? Well, we have to square it. So we're going to take our x minus 1/4 x, and we're going to multiply these together. I'm just going to write it this way. Being able to FOIL things out, that's like a very fundamental kind of a problem. We taught you that in intermediate algebra. When in doubt, FOIL. And we'll go ahead and do it this way. So we have x times x is going to give us x squared minus 2, right? Because we're going to multiply these guys together. So we have, this is going to be x times 1 over 4x. And there's going to be 2 of them, right? There's going to be this one that's the inners, and we're going to have one that's the outers. So we have 2x over 1 over x times 1 over 4x. Okay? And then we actually have the last, which is going to be negative times negative. So we have positive 1 over 16x squared. Okay. Well, the reason why this function looks so wonky is because something's going to happen really special here. We have an x is canceling with x. And then here we have 2 over 4, better known as a half. So we have x squared minus 1/2 plus 1 over 16x squared. What's the next step? We squared this thing out. Our next step is we're going to add 1 to this thing. Well, I can't add 1 to this piece. I can't add 1 to that piece, but 1/2 combines with 1 real easy. And we're going to say that's going to be x squared plus 1/2 plus 1 over 16x squared. And if I didn't know better, I would say that this line here looks a lot like this line without the plus 1, right? Looks a lot like that line right there. How did I get this line? Well, I multiplied out. I said this is x minus 4x squared. Now I've got a plus in here instead of a minus. You want to bet what this is going to factor into? Bet you do. It's going to be x plus 1 over 4x squared. Okay, so that's, we have our 1 plus f prime of x squared. We have to put this thing in a square root. I'm going to say, use this, my favorite math phrase of all times, and say the proof of this, the verification of this is left as an exercise to the viewer. You can square this thing out to make sure that this actually works out. It does. But then we're going to say, oh, we need the square root of x plus 1 over 4x squared. What was our interval again? Our interval went from 1 to 2. That's always going to be positive. We don't need absolute values. Wait, doesn't that work out nicely? So we have the interval from 1 to 2. Take the square root. We have x plus 1 over 4x dx. If that's not too bad of an interval, okay, we'll be able to do that. So let's see here. So we're going to be able to say that's going to be 1/2 x squared plus 1 over 4 natural log of x, going from 1 to 2. Again, should be absolute values, but we're going from 1 to 2. I know it's not going to be negative. Okay, so let's plug in some things. So we have 1/2 times 4 plus 1 over 4 natural log of 2 minus 1/2 1 squared. Okay, plus 1/4 times the natural log of 1. Boy, doesn't that work out nicely? Because natural log of 1 is 0, right? So we could say half of 4 is equal to 2. So we have 2 plus 1/4 natural log of 2 minus 1/2. Let's see here. I think that was it. And we'll be able to say 2 minus 1/2 is going to be 3/2 plus 1/4 natural log of 2. I think that's a perfectly good answer. Again, if you want to click this thing into the calculator, you're more than welcome to do it. 4 decimal places is what the standard is. Your engineering teachers will be so happy that you are doing the 4 decimal places. They will not be able to tell you. The other thing engineers really like, is you have to buy that paper with the squares on the back of it. You have to buy it for the engineering class. They love 3, 4, 5 triangles. If your little drawings of your engineering diagrams are 3 squares by 4 squares, and you use a straight edge to make that the hypotenuse for the 5s, don't ask me how they know, but they are going to look at you and say, Wow, you must be a really good student because you pay a lot of attention to detail. We are not always as standoff as you want to think. We're not, we're humans. There's bias. We can't get rid of it all the times. If your handwriting is nice, people tend to get higher grades. If you're perfectly good drawings that are 3 squares by 4 squares or the hypotenuse and everything is drawn with a straight edge, you get the benefit of the doubt. Like, oh, I think that's a 5 points out of 10. It's a 6. I think it's a 6. And it's not a lot that you're going to get, but you're going to get nudged up a little bit here and there, and it's going to pay off. Okay. So, problem number 5, let's go ahead. So, we're going to say, and this is going to be a very similar kind of technique. So, we're going to say, find the arc length, or calculate the arc length. We're saying, find. Calculate arc length of y is equal to x cubed over 6 plus 1 over 2x from, and I think we're going from 1 to 2 on this one as well. Yeah, from 1 to 2. Okay. I don't want to graph this thing. It looks like it's going to be so much fun. It's going to be a cubic over 6 or something like this. And then my 1 over 2x is going to be something like that. So when I add these up together, that's how I would do it. But we don't live in a world where you have to graph these things anymore. Okay, that was my undergraduate degree, not yours. All right. So again, let's go ahead and figure this thing out. So we have s is equal to the integral from 1 to 2 of 1 plus f prime of x squared as we're taking the square root dx. Okay. So let's start working through what we have to work through. We have an f of x, which is y. So we have f prime of x, and let's just figure that out. We have 3x squared over 6. Well, that's going to simplify. Plus, now here we have 1/2 x to the negative 1. Let's take our derivative. So we have minus 1/2 x to the negative 2. Okay, so that's what our f prime of x looks like. Okay, we can clean this up a little bit to say that's going to be 1/2 x squared, that's 3 over 6, minus 1 over 2x squared as such. Okay, this is my f prime of x. What's the next step? Well, we got to square it. So let's go ahead and do that. I'd recommend not pulling out the 1/2. You could, okay, it'll work out. But we're just going to leave it in because we're going to add 1 to this thing, and I want you to see something with that. So we have 1/2 x squared minus 1 over 2x squared. And we got to square this thing. So we have 1/2 x squared minus 1 over 2x squared. When in doubt, FOIL. All right. And then we're going to go ahead and just multiply this out. So we have 1/2 a half is 1/4. X squared times x squared is going to be x to the 4th. Then we're going to have minus 2, and we have our inners and our outers. Same deal that we had before. This is 1 over 2x squared. Let me clean that up a little bit for us. Okay. So we have 1 over 2x squared. Okay. Times 1 over 2x squared. So some things are going to cancel, but not everything. All right. So minus, and then we have our last. So that's going to be half times a half. So we have 1/4, x squared times x squared, x to the 4th in the denominator. Okay. So let's make sure that we're being careful about this. 1 over 4, x to the 4th, minus 2. Half times a half is 4. And look, we have an x squared on the bottom. We have an x squared on the top. Boy, that was convenient. It's almost like somebody planned it. Okay. So this is going to cancel out a little bit. So we have 1 over 4 x to the 4th minus 1/2 minus 1, or sorry, plus here. This is the plus. 1 over 4 x to the 4th. Now, what's the next step we have to do? We squared our f prime of x. Next thing we're going to do is we're going to add 1 to it. So we're going to go ahead and we're going to add 1. So negative 2 1/2 plus 1 is we're going to end up with 1 over 2 x to the 4th plus 1/2 plus 1 over 4 x to the 4th. And again, this, you're looking at this line here, or sorry, this line here and this line here, but boy, they look so familiar. This guy came from, where did this come from? This came from 1/2 x squared minus 1 over 2x squared squared, and now we change it to a plus. I'll bet what's going to happen here is we're going to have 1/2 x squared plus 1 over 2x to the squared. Again, you want to verify this. This is an exercise left to the reader or left to the viewer. Hey, if you got a friend taking intermediate algebra, outsource this to them. Make them multiply this out because it'll be good practice for them. For you, this is trivial, but for them, this is good practice. So we have this thing squared. Now we have to plug it back into the square root of 1/2 x squared plus 1 over 2x squared. What is our integral going from? 1 to 2? Oh, it's always positive. That's nice. We don't have to worry about absolute values. So we're going to end up with s equals the integral of 1 to 2 of 1/2 x squared. And I'm going to write this as plus 1/2 x to the negative 2, because what I'm going to be doing next is we're going to be taking an integral, and this form is easier to take an integral of than almost any other form that you want to deal with. Okay, and I think that's what we've got with this piece right here. I'm going to double check what I've got. Let's see here. You know what? I think that I'm not. Nope, nope, okay. Yeah, that's what I did. I forgot that part. Got a 1/2 on my notes. Okay, let's go ahead and integrate. So we have 1/2 x to the 3 over 3, so 1 over 3 here, plus, and then we're going to have x to the negative 1, because the negative 2 comes down in front. So we have negative 2. I'm sorry, we're integrating. We're not going to have 1 come down in front at all. Oops, sorry, we don't want that. We want this. Get out of here. Okay. So here we go. We have 1 over 2, but it's going to change to a minus for that one. What are we integrating to? 1 to 2. So here we have 1 over 6x cubed minus 1 over 2x, going from 1 to 2. Plugging this stuff in for getting an answer, that's not going to be too bad. So we're going to have 1 over 6 times 2 cubed is going to be 8 minus 1 over 4. Okay. And then we plug in our 1. We have 1 over 6. Plug in that minus 1 over 2. Let's clean this up a little bit, but for the most part, this is looking pretty good. So let's factor out a 2. So we have 4/3 minus 1 over 4 minus 1 over 6 minus a minus plus 1/2. We could plug this into a calculator. We could add this guy up really quick, but that's not a bad numerical answer to go ahead and get. So that works out pretty well. Okay, so those are good 3 examples of getting what is we're doing here? Arc length. So pay attention to the last 2 that we did here, because those forms show up quite a lot in arc length problems. So I just don't want you to be surprised, like, oh my goodness, these are so hard to factor. Like, well, they are if you've never looked at them before. They're not if you've done them before. Okay, so please practice. Try to make sure that you practice these enough so that this stuff does not take you by surprise. Thank you for watching the video. I'll see you in the next one, and take care until then. Good luck.